on Monday, we talked about hypothesis testing, right? It's kind of a new section. We don't really talk about it that often in real life. So we did a little activity to get used to it. We had a card activity. And after we did the card activity, we kind of summarized, right? And the first thing we did is we learned how to write these things called hypotheses, right? Now, a hypothesis is an educated guess, right? It's something that we think is going to happen. And before we even go into doing an experiment, we have this thing called a null hypothesis that we believe before we go in, okay? Now, if you don't remember, the null hypothesis uses the symbol H0, okay? You can come in. And after you write the null hypothesis, we put a little colon after it. Oh yeah, I didn't even pass them out yet. Oh. And whenever we talk about the null hypothesis, we always use mu, since these questions will always talk about the population mean. The null hypothesis always has an equal sign, and it's some sort of number like 15,000 to 0.7 something. Okay. On the other hand, we have this other hypothesis that we call the alternate hypothesis, which is basically the other thing that can happen. Okay, we use the symbol H1 with a colon after it. We're still talking about mu, and we actually use the same number to talk about the alternate hypothesis, but instead of an equal sign, we use less than, greater than, or not equal to. Okay, so that's kind of what we do. Okay. So on Monday, we talked about null and alternate hypotheses, and then we also talked about how to write our conclusions, right? Now, whenever we do an experiment, there's two options. We can either reject the null hypothesis, or we can fail to reject the null hypothesis, right? And I like making things simple. I think it's easy to remember templates. So if we write a conclusion, it's very important to say it the right way. And the way I like to remember things is to just kind of fill in the blanks. We're piecing together two parts of a sentence when we write our conclusion. And no matter what the question is, the end of the sentence is always going to be the alternate hypothesis or H1, okay? So mu is less than, greater than, or not equal to a number is always going to be at the end of the sentence, okay? Now, when we reject the null hypothesis, we always start with we conclude, okay? And if we fail to reject the null hypothesis, we always start with there is not enough evidence to conclude or say, okay? So honestly, I think it's just easy to remember the template. I'm a very simple person. Instead of just like kind of figuring out how to say it each time, just remember, start out with we conclude we're not enough evidence, and always end with the alternate hypothesis. Sorry. All right, so I think we're pretty good on what we did on Monday. Why don't I pass out the new set of notes and we'll talk about how to piece this all together. So what we're doing today is we're going to kind of piece everything together. So far, we've talked about how to write our hypotheses. We've talked about how to write the conclusion, but we haven't talked about like what we do in between, right? So when we go out and collect data and then we come to a conclusion, we actually have to figure out like, okay, how do I decide if I reject the null hypothesis or if I fail to reject the null hypothesis, right? Well, this is what we're going to learn in this section, okay? And the way that we're going to know how to do this is there's actually many different methods you can use for this, for these tests. We're going to learn this thing called the p-value method, okay? This is probably the most common method, okay? What we're going to do is we're going to learn how to take a bunch of data and come up with this number called the p-value, okay? And before I talk about what this number is, let me explain to you what the questions are going to look like, okay? So in this section, these questions are going to give you a bunch of information, okay? The first information you're going to get is, well, the null hypothesis, right? Which I wrote up there, but I guess we can copy down here. Mu equals some number, right? We also, I just wrote down the alternate hypothesis, so I guess I'll write that one down as well. Mu is less than, greater than, or not equal to some number, okay? The question's also going to give you a few symbols, okay? So it's going to tell you the population standard deviation, sigma, okay? We're also going to go and like collect a sample, right? So that sample is going to be of size n. And we're also going to know the mean of that sample if we calculate it, right? So we know that the sample mean is x bar, okay? Now, thinking back to the whole card example, well, in the card example, what we had is, well, we thought that the deck was 50-50 red and black cards, right? That's what we thought, okay? Then we did an experiment and we got 10 red cards and 0 black cards. And that made us really suspicious, right? Because, well, It's very improbable to get 10 red cards in a row, right? Then I asked you, okay, would you still be suspicious if I got 8 red cards and 2 black cards, or 7 red cards and 3 black cards, right? Once we get to that, it gets a little bit muddy if we should be suspicious or not, right? And basically the whole idea of this p-value method is to figure out where the line is drawn, right? When do we start feeling suspicious and where do we stop being suspicious, okay? And that's kind of the whole idea. So we're gonna take a look at this data. We're gonna figure out if we're suspicious enough to reject the null hypothesis, or if we're not really sure, there's not enough evidence to do that. All right, we're gonna do that by calculating this thing called the p-value. Now, before technology existed, and some classes still do this, the p-value is a number that you calculate, okay? And in a lot of different classes, you're actually expected to do that by hand, and use a bunch of charts to find this p-value. I promise you that method is crazy. It is very technical, and you will have a very bad time if you calculate a p-value by hand. We're actually going to do it using Minitab, and because we're just using Minitab to find it, I don't actually expect you to know what the p-value is per se. I wrote something about what it is. The only thing I need you to know about the p-value is, one, you use the central limit theorem to find it, okay? That's one thing you do with the p-value, okay? The other thing I need you to know about the p-value is if you have a really small p-value, then you have enough evidence to reject the null hypothesis, okay? If the p-value is too large, then you don't have enough evidence to reject the null hypothesis, so you fail to reject, okay? Okay, now if that doesn't make any sense, let's just flip to the next page and see what's going on, okay? So one other thing that I didn't tell you is these questions are going to give you another number, okay? And this number is called the significance level, okay? This significance level, we're going to call it alpha. Okay, so now we have a brand new symbol. I know we have a billion symbols in this class, but alpha is the significance level. You don't really need to know what it is per se, because we'll talk about that a little bit later. Just know it has something to do with the confidence level when we were doing confidence intervals. The question just gives it to us. Okay, so with the significance level, if your p-value that you calculate is less than alpha, we're going to reject the null hypothesis. Sometimes we call it statistically significant. I don't really use that term. Maybe the final exam might use that term, but I won't use it, okay? If p is greater than alpha, we don't reject the null hypothesis. Another way to say don't reject is fail to reject, right? Fail to reject. Okay, so basically, if p is smaller than alpha, reject. P is greater than alpha, fail to reject. Okay, why don't we do some practice with this? Okay, let's say we did an experiment, and we found that the p-value was equal to 0.0122. Okay, now, do we reject or fail to reject? It actually depends on what alpha is. Okay, let's do example number 1. Okay, do we reject HO at alpha equals 0.05? Okay, now whenever I do one of these questions, I don't know if it's just me and my brain, but I can't compare two numbers if I don't write them side by side. So you don't have to do this, but for some reason, I can't do this unless I do this. I write p on the left, I write alpha on the right, and I stack them right next to each other. So p is 0.0122, alpha is 0.05, and for some reason, the only way I can figure out which one is smaller or bigger is if I write them side by side. If I don't do it, I just can't do the problem. Okay, so if you ever get confused by that, just try writing them side by side. I don't know, my brain just doesn't work. Okay, which one is smaller, p or alpha here? P, right? P is definitely smaller, okay? And if p is smaller than alpha, do we reject the null hypothesis or fail to reject? Reject, perfect. So we reject HO. Okay, and it's really as simple as that. Just figure out which one's smaller. If p is smaller, we reject. I'm just going to write p and alpha next to each other. P is still the 0.0122. Alpha is the 0.01. Which one is smaller this time? Alpha is definitely smaller, right? So p is greater than alpha. Do we reject or fail to reject? Fail to reject. Perfect. Fail to reject. HO. Okay, so it's really pretty simple. All you have to do is figure out which one's bigger, and then decide if you reject or fail to reject. Okay, so you're probably wondering, well, how do I find P in the first place, right? Now that's kind of the only missing thing. Well, I'm going to show you a few steps on how to do these whole problems. Remember that whenever I introduce P, we use the central limit theorem to find it. If we use the central limit theorem, we have to answer that first assumption problem, right? If we don't follow the assumptions, we can't do the problem, okay? So before you do these problems, first of all, answer, is the sample size large enough or is the population normal, right? That's the first thing you have to do. The other assumption is sigma given to us? If you're wondering why I'm asking that question, it's because, well, there's going to be questions where sigma is not given to us, and there's a whole different process we do for that. So don't worry about that right now. We'll come back to it. Okay. Step 2, writing our null and alternate hypothesis. Pretty sure we know how to do that for Monday. Okay. Step 3 is something I didn't really talk to you about. Okay. We're given a significance level. Okay. But the significance level isn't something that Minitab takes. Okay. Minitab only takes this thing called the confidence level. Does anyone remember what the confidence level is? Yeah, here's some nod, right? I see some nodding here. The confidence level, if you remember the confidence interval section, remember that percentage, like 80%, 20%, 25%? There's actually a relationship between this significance level and the confidence level. They have a relationship, okay? And the relationship is this equation, okay? So if you ever ask what the confidence level is, well, this equation is something I need you to memorize. Okay, it's really not that bad. Okay, and it allows you to go from alpha to the confidence level. And that's what Minitab takes. And that's the reason that we're even talking about in the first place. Okay, so we found our confidence level. Step 4 is Minitab. Okay, now I know a lot of you hate Minitab because of the probability section. I promise you, using Minitab is so much easier than it is to do these questions by hand. I know some other classes make you do this by hand. Hannah, did you have to do this by hand? Okay, was it hard? Yeah, it's hard. It is not fun doing these questions by hand, which is why I'm not even going to tell you how to do it, okay? If you want to learn it, go ahead, have fun. But I promise you, even though the instructions look bad on Minitab, Minitab is so much easier than doing these questions by hand. I promise you're going to thank me for this, okay? The biggest thing on Minitab is this uses the one sample z-test. So I'll show you how to do it when we do a question. I think it's easier to explain by person. You kind of just fill in the blanks and it gives you the answer, okay? Promise you, so much easier. Okay, step 5, decide if we reject or fail to reject. Well, we already did some practice doing that. And then step 6 is writing your conclusion, just like we did on Monday. Okay, why don't we just piece this together, do a problem. I'll show you what to do on Minitab, and it'll all make sense when we go through it like that. Okay, flipping our page. Whew, okay, these questions are really large questions. They are like a whole paragraph long. I think the hypothesis test questions are even longer than confidence interval questions. You're given a lot of information. So what I like to do is as I read through, I just write down all the information. So then I don't have to go back and read the question anymore. Everything's already written down. Cool. Okay, example 1, the mean height of adult men in the US is 70 inches. Oop, we got a number. Okay, that's definitely a mean. Well, do you think this mean is a population mean or a sample mean? Population, right? Because, well, we're not really given a sample yet, so there's no talk about a sample. And it even says like all the adult men in the US. That sounds like a population to me, right? So let me just write down mu, population mean symbol, equals 70, okay? With a standard deviation of 3. So is 3 population or sample? Population, right? Still didn't talk about the sample yet. And it's in the same sentence as the population mean. This is sigma. Sigma equals 3. Okay. Sociologist believes that taller men might be more likely to be promoted, blah, blah, blah. Once we get to this sample, we have a simple random sample of 100 male business executives. Looks like, well, that looks like a sample size to me, right? N equals 100. It says a simple random sample has a mean height of 70.3. 70.3 is definitely a mean. has to be the sample mean because we already wrote down the population mean, right? You can't have two population means. You only have one number, that's the sample mean. 70.3 has to be X bar. Okay. Then it says, assume that the standard deviation of male executive heights is 3 inches. We actually already wrote that down, so I'm not going to write it twice. Okay. Can we conclude that male business executives are taller on average than the general male population at the alpha equals 0.05 level? I'll just write that down as well. Okay. So we got through the scary paragraph. We don't have to go back and read it because all our information is written down over here. Also, I think my font is like, I don't know. I feel like I need to write in a little bit darker ink. Okay, there we go. Let's do step one. Step one is stating our assumptions. The first assumption is about sigma, right? Now, don't really worry about it now, but these questions do rely that sigma is given to us. Yes, it is. Sigma is given. Okay, that was easy. Second question, is the sample size bigger than 30? Is 100 bigger than 30? Yeah, right. So it looks like we are done. That gets a smiley face. Okay. There's a fly in this room and it's bothering me, but that's okay. All right, step two, stating the null and alternate hypothesis. So when we write the null hypothesis, it always follows the same instructions, right? We write H0, we put a colon, we're always talking about mu being equal to something. And what number is mu equal to? 70, perfect. And this is actually why I write down all the information before I do the question. If you don't write this down, then you're gonna have to go back and figure out which one's the population mean, which one's the sample mean. I think it just takes too much of your time to go back in the question, which is why it's really nice that it's written right here, right? U equals 70, write it down again. Okay. H1 is the alternate hypothesis. Mu stays the same. The number actually stays the same. But are we using a less than, greater than, not equal to symbol? What do you guys think? Greater than. And why is it greater than? Yeah, take a look at the question. It says, can we conclude that the male business executives are taller, right? So if there's anything in the question that says bigger, smaller, taller, shorter, wider, narrower, something like that, that talks about greater than, less than, that tells you what symbol goes in here. So since it says taller, definitely greater than symbol. Okay. Now, my biggest hint to you is if you're trying to figure out what symbol goes in the alternate hypothesis, the last sentence of the question will usually tell you that, because the last question is what we're interested in, what we're trying to figure out about the hypothesis. So just take a look at the last sentence of the question, see if it says bigger, smaller, taller, shorter, something like that. That will tell you what your alternate hypothesis is. Okay. Let's move on to step number 3. What is the significance level? Well, I wrote that down up here. Alpha equals 0.05. That was easy. Then it also says to calculate the confidence level. Okay. Who remembers how to find the confidence level?
1 minus alpha. Just make it
Perfect. Or 100 times 1 minus alpha. Oh my God, 1 minus alpha. Perfect. If you ever forget this formula, it is on the back page of this paper, right? So confidence level equals 100 times 1 minus alpha. That's the formula. I want you to memorize, know how to do that. This is the formula. Okay. Pretty easy to plug this in, right? 100 times 1 minus 0.05. Okay. I like to do the subtraction first. So 100 times 0.95. Change that to a whole number or multiply by 100. We get 95% as our confidence level. Okay. So we're basically translating alpha into like the number that we get in confidence interval questions. Okay. So we did all the pre-work. Let me show you what to do on Minitab. Okay, I promise you, even though the instructions look a little crazy, it's a lot easier to do this on Minitab than doing this by hand, I promise you, okay? So what I'm gonna do is I'm just gonna flip to this page. I'm gonna follow through the Minitab instructions. I'll show you what to click on Minitab here. I'm pulling up Minitab, okay? And this is what I'm gonna do. I'm gonna click on Stat. I'm gonna click on Basic Statistics. And then up here, we have all these different tests, like one sample Z, one sample T. We're actually going to learn how to use all of these tests later on in this class. But what we're going to do for now is one sample Z. Click that. Okay. And we get to this box here. Okay. Now, you might be wondering, what do I do here? There's not much to fill in until you click on this drop-down menu and change it to summarize data. And the reason we're doing that is because we're given like a summary of all the data, like the sample size, sample mean, stuff like that. Well, we can just fill in the blanks. Once we're here, it's pretty easy, right? I mean, sample size, we wrote that down to be 100, so I can type that in. Sample mean, I wrote that down, that was 70.3. Okay. Known standard deviation, well, the question only gives us one standard deviation, so that has to be 3. Okay. Once we're done that, we are doing a hypothesis test, so it makes sense to click perform hypothesis test, right? Hypothesize mean, well, looking at our null and alternate hypothesis, the number in there is 70. Okay. And at this point, it's really, really tempting to click OK, right? It makes you like, you really want to hit OK, you want to get the question done. But before you do that, stop and click options. Okay, so you can click the options bar. Okay. Once you're here, you have the chance to write down your confidence level and also what it says in the alternate hypothesis. Confidence level, we calculated to be 95. The alternative hypothesis has 3 options. We have a less than, not equal to, or greater than. Okay. In this case, well, our question says greater than, so I'm going to switch it to greater than. Okay. Once we're done that, click OK. Click OK. And what we get here is we get a, oh no. Oh no. Okay. Oh, it actually saved it for us. Good. Okay. We get a lot of information. We get some statistics based on the information that we gave. And if you scroll down, we have the important stuff. Okay. Under test, we have the null and alternate hypothesis. Good. We have this thing called the z-value. I wouldn't worry about that. If you were doing it by hand, you would calculate the z-value, but we don't really care about that. What we really care about is the p-value, right? The p-value is the important stuff. That is the number that we want. Okay. Any questions on what to click on Minitab? So what I did on the next page is I just kind of like put a screenshot of what you see on Minitab. What's really important here is the p-value, right? That's the most important thing on here. Okay. So the p-value is definitely 0.15. Okay. Step 5, deciding if we reject or fail to reject null hypothesis. Does anyone remember what to do for this step? Perfect. Compare P and alpha, right? That's where I write P and alpha next to each other. I always write P on the left, alpha on the right. I think that helps me to keep it like consistent like that. Looks like P is 0.159. If you ever forget where to find alpha, well, we wrote it in the very beginning on the first page. Alpha is 0.05. And it looks like P is definitely bigger than alpha here, right? Okay. If P is bigger than alpha, do we reject or fail to reject? Fail to reject. Perfect. So we fail to reject HO. Okay. And once we decide to write that we're failing to reject, all we have to do is write out our conclusion, right? Now, when we fail to reject the hypothesis, we always start out with there's not enough evidence to say, right? So there is not enough evidence to conclude. Okay, and we always end the sentence with H1. So whatever H1 says, let me just take a peek. H1 says greater than 70. Well, I'm just gonna write that down. Mu is bigger than 70. Okay. Any questions on what I've done here? Perfect. All right, so how about this? If you flip to the next page, we have another very similar example. Why don't we work through this for a little bit? I think we have enough time to get through this. Let's go through this one. Remember, we have the large, scary paragraph. Let's just read through it, write down all the information so we don't have to ever go back to the scary paragraph. Okay. So we have a test. The scores range from 0 to 100. That doesn't really matter with the question, so I'm not going to write that down. Let's see, the mean score of all the company's employees was 74. Is that population or population or sample mean? Population, perfect. I think we're all experts in determining that. With a standard deviation of sigma equals 8. I love it when the question gives us the symbol, right? We don't even have to worry about what it means. Okay, we have a policy of telecommuting. This question was written before COVID because the textbook came out before COVID. So it's kind of strange how they're talking about telecommuting before COVID happened, but I feel like it's not too big of a deal now. All right. After the policy had been in place, we took a random sample of 80 workers, n equals 80. They were given blah, blah, blah. The sample mean was 76. Literally tells us it's the sample mean, X bar. And assume the standard deviation is sigma equals 8. Oop, I already wrote that down. Finally, it tells us that alpha is 0.05. Perfect. So we have all the information. Let's just go into the assumptions. Step 1, stating the assumptions. Sigma given to us? Yes, it is. It's right there, right? So yes, sigma is given. Okay, gets a smiley face for that. Is the sample size bigger than 30? Well, is 80 bigger than 30? Yeah, perfect. 80 is definitely bigger than 30, so we definitely get a smiley face there. We can go on to step number 2. All right. Step 2, stating the null and alternate hypotheses. The null one's pretty easy, right? Because we just have to write HO. We're talking about mu, and since I already wrote what mu was up top, I don't have to think about what number to write. I just have to copy it down. Okay. The alternate hypothesis is a little bit scarier, right? It's basically the same symbols, except we're using H1. But instead of an equal sign, we have something different, right? Now, my hint to you was, if you don't know what symbol to write for the alternate hypothesis, take a look at the last sentence, because that will tell you if it's greater than, smaller than, whatever. What symbol am I writing? Greater than, smaller than, not equal to? Not equal to. I think we're all good on that. That makes me very happy, okay? And it's not equal to because, well, it's asking if the mean level of satisfaction is different, right? It's not telling us greater, smaller, taller, shorter, wider, narrower, anything like that. It just says different. So if it says different, we just write not equal to. Okay. Any questions so far? Sounds good. Next is the significance level. We already wrote down that alpha was 0.05. That is the significance level, so we're good, okay? Confidence level, just plugging in the formula, right? So I'm just gonna write CL for confidence level. Think we all know what that is. 100 times 1 minus alpha is 100 times 1 minus 0.05. So we're really multiplying 0.95 times 100 to get us 95%. Okay, so we have enough information to go into Minitab. I know it's kind of overkill, but let me just show you what I'm typing into Minitab so you can see it again. Honestly, just following the instructions is good enough for me. But basically, all we do is you click on Stat, Basic Statistics, and One Sample Z. Once you're here, you do have to switch that top part into Summarize Data, so make sure it's there. And after that, you're basically doing the same thing, right? You're filling it. You don't really have to memorize what to do because it's telling you type in the sample size. Sample size is 80 this time. Type in this. Oh, yeah. Type in the sample mean, 76, right? Known standard deviation is 8. Okay. We're clicking hypothesis test. The hypothesized mean is 74, right? Under options, remember, click this before you hit OK. Make sure that the confidence level is still 95. And the alternative hypothesis says not equal to. So I'm not going to change that. Looks like we're good. Going to click OK. Click OK again. And what we get is a bunch of information. Okay. One thing I forgot to talk about is up top, under descriptive statistics, we actually do get a confidence interval, okay? When you do your Minitab lab that's due next week, Tuesday, you'll actually learn how to do confidence interval questions without actually having to use the tables. And the One Sample Z test actually does it for us. So something cool about Minitab. But if you scroll down, we'll see the hypothesis test. Looks like the p-value is 0.25. So I kind of just copied what Minitab showed. The p-value is right here, 0.025. Okay. And if we decide to reject or fail to reject, remember, write p and alpha next to each other. P is 0.025, alpha is 0.05, and p is definitely smaller, right? Okay. So if p is smaller than alpha, did we reject or fail to reject? Reject, perfect. And if we reject the null hypothesis, what do we start a conclusion with? We conclude that, okay, conclude that. And what do we always end the sentence with? Perfect, the alternate hypothesis H1, which says mu is not equal to 74, right? Okay. And well, that's how we do these problems. You just have to follow the steps in order.